Alright, this is a video for 9.1 part 2. I'm just going to jump straight into it, and here we go. Alright, so the first thing we're going to do is, in part 2, we're going to convert, just like we did in the previous lesson, or for part 1, converting a rectangular coordinate point, xy, into a polar point. So just as a quick review, remember xy, we know a rectangular is an xy coordinate. Polar is what we learned yesterday, is r comma theta, right? Theta is, we're going to keep it in radians for our unit. I'm going to go out of order, and I'm actually going to do this example of 3 comma 5 here, all right? This is in quadrant 1, okay? So I'm going to draw this point in quadrant 1. Like this. Okay. We know this point is 3 comma 5. That means this is 3 and that's 5. And by Pythagorean theorem, we can figure out the hypotenuse here, right? This turns out to be square root of 34, okay? Because of 3 squared plus 5 squared equals r squared. All right, that's square root of 34, and that's your r. All right, we're halfway done. Okay, now for theta, right, we know that theta is right here. Right. Remember, we call this, what I'm highlighting, this is the pole axis. We want this angle to be our theta. And yesterday, I think what we did was we used the tangent relationship. Right, so tangent of theta is equal to y over x. And so theta is the inverse tangent of y over x. So in this case, that's going to be 5 over 3. And so you're going to have to, I'll make a little note here, all right? You're going to need a calculator here. Because 5 over 3 is not a unit circle value. And so you're going to make sure that you're in radian mode, okay? And you do the inverse tangent of 5 over 3, and you should get 1.03, and that's going to be radians. And that's with theta. So your coordinate point of 3 comma 5 in polar is going to be root 34 comma 1.03. Okay, so going to the first one now. Right. The reason I'm going out of order is because the first one, there's something with the calculator that I want to clarify, and I didn't want to confuse you right from the get-go. All right. So this coordinate point, negative 5, 4, right? We know this is in quadrant 2. Okay. And so I'm going to draw my triangle and plot this point in quadrant 2. Right, negative 5, 4, something like this. Okay, and again, by Pythagorean theorem, we can figure out what the r value is going to be. Right? R squared is equal to 4 squared plus negative 5 squared, and r turns out to be the square root of 41. That's your R value. Okay. Now for the theta, right? We know we're going to use the inverse tangent of 4 over -5. Okay. Actually, I'm going to use a positive 5 instead of a negative. Because when we do the inverse tangent there, the negatives don't really, it won't matter too much. Okay. So let me adjust this real quick. That's going to be 4 over 5. Okay, now, when you go to your calculator though, and when you do the inverse tangent of 4/5, make sure you're in radian mode, you'll get an angle of 0.67. Now, you got to think about what you get here as an answer. That should be a red flag for you, because your angle is in quadrant 2, right? But if you look at 0.67, that's not even 1 radian. This angle is actually in quadrant 1. So I'm going to put quotes around here because the 0.67 is actually referring to the reference angle. Okay? So what that means is, well, if that's the angle inside the triangle, 0.67, we need the angle from the 0 degree mark, right? And so we need this angle. Well, how do we figure that out? The angle then is actually pi minus 0.67, right? Because pi is your 180 degrees. Well, we can't use 180 degrees because we're in radians, so we're going to use pi, okay? So your theta is actually approximately 2.47. All right. So this rectangular coordinate, in terms of polar, is going to be root 41, comma 2.47. Okay. You're also going to have to convert equations, all right, not just polar coordinates. Okay, but before we get into that, I want to remind you of these equations and relationships from the last unit. That's going to pop up right now. So we have these relationships for cosine and sine, all right? But actually what I'm going to do is I'm going to solve for x and solve for y individually. And so what I end up with is actually, I'm going to go out of order, y is equal to r sine theta, just multiplying by r on both sides. And over here, x is equal to r times cosine theta. So we're going to use this one, and this one a lot. Okay. So here's a polar equation, r equals 6 cosine theta as our first example. Now when we convert from polar to rectangular, right, we need, since we're going to rectangular, we need x and y, right? That's what rectangular means. We're trying to get rid of anything with an r or anything with a theta, right? So here's what I'm going to do for this first one. Remember in math, you can always manipulate as long as you do to both sides of the equation. So what I'm going to do here is I'm going to multiply both sides of the equation by an r, right? So on the left side, I get r squared equal to 6 cosine theta times r. All right. I'm actually going to, if you look on the right side, I'm going to take this r, and since we're multiplying, the order doesn't matter, we can move things around, right? Commutative property. So this is r squared is equal to 6 times r times cosine theta. And the reason I did that is because, now look, we know r squared, if you look over here on the right, r squared is x squared plus y squared. And then here, r cosine theta is over here. That's equal to x. So that's 6 times x. And that's it. As long as we have just x's and y's, we're good. There's no r variable and there's no cosine theta. You don't even have to bring that 6x over if you don't want to. You could just leave it like this. Alright. Now some people prefer to bring it over, and you could write it as x squared minus 6x plus y squared is equal to 0. Alright. Let's look at one more example here. Alright. You have r equals sine theta plus 1. And again, I think the key part is we want the easiest way to get rid of the r is to somehow get it to be r squared, right? Because we know that, again, r squared is equal to x squared plus y squared. So what I'm going to do is, again, I'm going to multiply by r on both sides. You got to be careful that on the right side, you add in these parentheses. Okay. So then this is going to be r squared is equal to, I'm going to distribute the r. So that's going to be r sine theta plus r, right? So for now, I'm going to change what I can. I know that, again, r squared is x squared plus y squared, and r sine theta is y plus r. Now, so we have a problem, right? We still have this r, so we're going to have to square it, but I don't want to square this just yet, because if I do this, now I have to FOIL y plus r squared. So I don't want to do that, and instead what I'm going to do is I'm going to subtract the y over to the other side. So I've got x squared plus y squared minus y is equal to r. And at this point, I'm going to multiply by r. Or I'm sorry, I'm not going to do that. Nope, it's not what I meant. Instead of multiplying by r, what I'm going to do is I'm going to square both sides. Right? So again, r squared is x squared plus y squared. Now you might be thinking, well, I don't want to, what do we have to do here? Are we going to have to multiply all of this out? No. Right? As long as you just change everything to x's and y's, that's it. You're done right here. Okay? So I'm going to have to make another video, because I only get 15 minutes per video. Alright? But I would say try this as a challenge, or like a try your own kind of thing, before you go on to the other video. Alright? So try this one, convert it into rectangular.